Deep learning, a subset of machine learning, is inspired by how the human brain functions and has emerged as a transformative tool in various sectors, including finance. It enables computers to make independent decisions based on large data sets, revolutionizing areas such as fraud detection, algorithmic trading, customer service, and risk management. Neural networks and pattern recognition. Deep learning are neural networks with multiple layers, known as deep networks. These networks excel at identifying complex patterns in vast datasets, patterns that often go unnoticed by human analysts. In finance, these patterns help predict market trends, assess investment opportunities, and flag risky transactions with high accuracy. Fraud detection. One of the most significant applications of deep learning in finance is fraud detection. Financial institutions process vast volumes of transactions, making it challenging to identify fraudulent activities. Deep learning models, trained on historical data, can detect signs of fraud by analyzing thousands of variables in real time. This rapid detection helps reduce financial losses from fraudulent transactions. Algorithmic trading. Deep learning has made a profound impact on algorithmic trading. Traders and fund managers use deep learning algorithms to analyze historical and real-time market data, enabling trades at optimal times. These algorithms learn from price patterns, trading volumes, and economic indicators, helping create dynamic trading systems that adjust to changing market conditions. As a result, trading strategies become more informed, potentially leading to higher investment returns. Personalized financial services. Deep learning enhances customer experience through personalized financial services. In wealth management, for instance, deep learning algorithms analyze individual investment behaviors and tailor financial advice accordingly. By considering past decisions, risk tolerance, and financial goals, these systems can offer personalized product recommendations, improving customer satisfaction significantly. Credit scoring and risk management. Traditional credit scoring models rely on limited indicators like income, credit history, and loan repayment records. In contrast, deep learning models enable more nuanced credit assessments by incorporating diverse data points, such as rental history and social media activity. This leads to more accurate credit scoring, allowing financial institutions to extend credit to underserved markets without increasing risks. Risk management is another area where deep learning proves valuable. Financial institutions use deep learning models to simulate economic scenarios and assess potential portfolio impacts, enabling them to devise strategies to mitigate risks and better prepare for economic fluctuations. Challenges of implementing deep learning in finance. Despite its advantages, implementing deep learning in finance comes with challenges. Deep learning models are computationally intensive and often function as black boxes, making their decision-making processes difficult to interpret. This lack of transparency is problematic, especially in a regulated industry like finance. Additionally, the accuracy of deep learning models depends heavily on the quality of data used. Biased or incomplete data can lead to poor predictions and flawed decisions. Ensuring the integrity of training data is essential for successful implementation. Future of deep learning in finance. The future of deep learning in finance looks promising as computing power and algorithms continue to advance. As models become more interpretable and manageable, their applications are expected to expand. The potential for more sophisticated, efficient, and secure solutions in finance is significant, with deep learning likely to play a crucial role in further transforming the industry. Reinforcement learning, advanced strategies. Reinforcement learning, RL, is an advanced branch of artificial intelligence focused on learning optimal actions through trial and error. Unlike deep learning, RL does not rely on labeled data. Instead, it learns by interacting with its environment, receiving rewards for favorable actions and penalties for undesirable ones. Evolution of reinforcement learning. Reinforcement learning has evolved considerably, especially with the rise of deep reinforcement learning, which combines deep learning with RL. This combination enables algorithms to process complex inputs such as images and data arrays. Examples include DeepMind's AlphaGo and OpenAI's bots, which have shown RL's advanced capabilities by outperforming human champions in strategic games. Applications of reinforcement learning. In robotics, RL allows machines to learn complex tasks, like walking or flying, by interacting with their environment. In finance, RL is used to develop sophisticated trading strategies, enabling systems to adapt to new information and market conditions dynamically. Challenges of reinforcement learning. Reinforcement learning faces challenges, particularly in aligning reward systems with beneficial outcomes. Misaligned rewards can lead to unintended behaviors. Additionally, like deep learning, RL can function as a black box, making its decisions difficult to interpret. As RL continues to expand into real-world applications, transparency and ethical considerations become critical. Hybrid models in machine learning. Hybrid models, which combine multiple machine learning techniques, are increasingly popular for addressing complex problems. By leveraging the strengths of different approaches, hybrid models can enhance accuracy, particularly in finance and healthcare, where precise decision-making is essential. Advanced natural language processing for financial documents. In the financial sector, managing large volumes of complex documents efficiently is crucial. Advanced natural language processing, NLP technologies are transforming how financial institutions handle documents like contracts, reports, regulatory filings, and customer communications. NLP not only automates document processing, but also helps extract deeper insights, enhances compliance, and improves customer service. NLP allows machines to interpret human language, which is vital in finance due to the specialized terminology and intricate details often found in financial documents. Manual document processing is time-consuming and error-prone, whereas NLP automates these tasks, ensuring greater speed and accuracy. Understanding the content of financial documents. One of NLP's key functions in finance is information extraction, identifying and retrieving specific data, such as dates, monetary values, and financial metrics. For example, NLP can analyze earnings reports and extract crucial statistics like revenue growth or operational costs without human intervention. NLP also helps classify and categorize documents, making it invaluable for regulatory compliance. By reviewing thousands of documents, NLP systems can flag potential compliance issues, minimizing the risk of regulatory breaches. Sentiment analysis for market prediction. Sentiment analysis is another advanced application of NLP in finance. It assesses the tone of textual data, determining whether the sentiment is positive, negative, or neutral. Financial institutions use sentiment analysis to gauge market sentiment from news articles, analyst reports, and social media. This helps traders and investment managers predict how events might affect market conditions and make informed decisions. Risk management NLP also plays a significant role in risk management by analyzing financial documents for potential risks. From credit agreements that highlight default risks to investment documents outlining market volatility, NLP systems can assess risks automatically, empowering financial institutions to manage and mitigate them more effectively. Enhancing customer interactions, NLP improves customer service by powering chatbots and virtual assistants capable of handling routine inquiries like account issues or financial advice. For more complex inquiries, NLP tools assist human agents by quickly retrieving relevant information from documents, enabling them to provide more efficient service to customers. Challenges in integrating NLP. Despite its potential, integrating NLP into financial systems presents challenges. Financial documents often contain ambiguous terms or context-specific language, which NLP systems may struggle to interpret. Continuous training and refinement of NLP models are necessary to handle these nuances effectively. Ethical considerations, particularly regarding data privacy and security, also arise when implementing NLP. Financial documents contain sensitive information, so ensuring compliance with data protection laws is crucial. Looking forward. As NLP technology evolves, its applications in finance will become more advanced. Future models may be capable of understanding intricate financial jargon. With widespread adoption, NLP is poised to revolutionize the financial sector by unlocking greater efficiencies and insights.